Okay, so this is your unit 2.1 test review. Most of the answers are given, not all, and your total review is worth 15 points, and you will turn it into class. Part 1, given the functions f of x equals 3x plus 2 and g of x equals x squared minus 5, determine the values of the following composition of the functions, okay? When we talked about composition of functions, it means that it's inside first. So we're going to start with the inside, the innermost of the notation. So we have g of 2. So the first thing we're going to do is figure out what is g of 2. Well, g of 2 means that I'm substituting in 2 for x in the g of x function. So that's going to lead me to having f composed of, and instead of a 2, it's going to be 2 squared minus 5. I'm going to simplify this, and that's going to give me f 4 minus 5, which equals f of negative 1. So now I'm going to take the negative 1 and I'm going to substitute it into f because that's f of negative 1. So where x is going to become a negative 1. So we have 3 negative 1, which equals negative 3. So my final output is negative 3. I'm going to leave you to do g, and we'll talk about 3. 2, and we're going to talk about 3. So my innermost is g of 3, so I'm going to substitute 3 in for x of g of x. That's going to give me g, substituting in x, and that gives me 3 squared minus 5 equals, and that's going to lead me to 9 minus 5 equals, and that gives me g of 4. So now I'm going to substitute 4 back into g, and it gives me 4 squared minus 5, which equals 16 minus 5, which equals 11. Okay, so that's composition with numbers. Now let's look at it with functions. All right, so now we're on to 4 and 5. Again, I'm going to let you do the even, and I'm going to do the odd in this situation. So here it says f composed of f of x. So just to set you up, you have f of x in the innermost. So whatever f of x equals, that's what you're substituting in. So you have f of 3x plus 2. I'll let you finish that out. Now I'm going to do g composed of g of x, starting with the innermost. The inner is x squared minus 5. So we have g parentheses x squared minus 5. So what this is saying, everywhere there's an x in g of x, I'm going to put, so everywhere there's an x in g of x, I'm going to put in x squared minus 5. So we have parentheses x squared minus 5 squared minus 5. Okay, after I've replaced that, now I'm going to clean this up and simplify. This square means that I have 2 of these. So this expands to be x squared minus 5 times x squared minus 5 minus 5. And now we're going to use FOIL, the FOIL algorithm. So we're going to have first x squared times x squared gives us x to the 4th. X squared times negative 5 gives us negative 5x squared. Negative 5 times x squared gives us negative 5x squared. And negative 5 times negative 5 gives us positive 25. We're going to bring down our negative 5 that's already there. We're going to clean this up, simplify it. So that gives us x to the 4th minus 10x squared plus 20. That would be our composed function, simplified. Okay. 6, I'm going to let you finish it, and then I'm going to do 7. So we have g composed of f of x. My innermost is f of x. F of x equals 3x plus 2. So we have this equals g at 3x plus 2. And then you're going to finish it from there. Okay. I'm going to do 7. So we have f of g of x. My innermost is g of x. G of x is x squared. So this equals f of x squared. Probably get the x first, of x squared minus 5. So everywhere in f of x where there's an x, I'm going to replace it with x squared minus 5. So this equals 3 times x squared minus 5 plus 2. I'm going to distribute, so distributing And that gives me 3x squared minus 15 plus 2. Continue to simplify, and I get 3x squared minus 13. That's my simplified function. All right. On part 2 of our review, we're talking about compositions or transformations with absolute value. And so basically you have a function and you're taking that function and you're composing it using absolute values, which we did in class. So in class, we talked about letting f of x be something, and then we let g of x equals the absolute value of x, right? And we did compositions with f of x and g of x, okay? So this is essentially the same thing that we have here. If we have this one, this means that we have g composed of f of x. So this would be g composed of f of x if we're referring to our notes. So I'm taking f of x and I'm putting inside of g of x, okay? Here we have f of absolute value of x. So this is f composed of g of x. So that's the comparison or the tie between our notes and the graphs you have here. Okay? So graphically, let's look at what we have here. This is our original function, and we want to take the absolute value of f of x. Absolute value of f of x essentially means we're taking the absolute value of our y variables, right? And so our y values are going to be what's changing. When you're taking the absolute value of something, that means that if it's negative, it's going to turn positive. If it's positive, it's going to stay positive. Okay, so let's start. Let's identify some key points that we are going to change to help us through the transition. Okay, so if you look here, everything's counting by ones. So if I'm halfway in between, then that's going to be like a halfway point. So we have negative 10, 0 here. Okay, I'm going to identify this point. We're going to say that this is at negative 7.5, comma 8. Here we're at negative 5, comma 0. Here we are at, it looks like negative 2.5, negative 2.5, comma negative 8. Here we're at the origin, 0, 0. We're here at positive 2.5, comma 8. We're here at positive 5. We're here at positive 7.5, comma 8, negative 8. And we're here at 10, 0. Okay. If for viewing, you also can make a table, which would make it easier for you if you wanted to see. And now we're going to transform. So if I have the absolute value of f of x, that means that the values that have negative y's, they're going to turn into positive y's. If it doesn't, then I'm going to leave it alone. So for example, we have negative 10, 0. Well, negative 10, 0, 0 is going to stay 0. Okay, we're at negative 7.5, 8. So at negative 7.5, 8, it's just going to be negative 7.5, 8, because my y is already positive. Okay, and then we're at negative 5 zeros, so they're going to be at 0. Now, negative 2.5 and negative 8 are going to go up, because instead of a negative 8, we're going to have a positive 8. Okay, so our origin is going to stay our origin. Our positive 2.5, positive 8. I don't think I'm quite at the halves, y'all. As I see now, I know I'm not at the halves. Not that I'm not quite, I'm clearly not. That's the half. That's the half. Halfway. And then we're at 5, 0. Then we're at 7.5. At 7.5, instead of being negative, it's going to be positive. And then we're at 10, 0. So identifying the points from the current graph makes it easier for me to know what's going to have to become positive. And now I'm just going to connect my dots. So we're going to now pretend that these are the most curvaceous lines, and I'm going to try really hard, y'all, to make it go through all the points equally. I think I put too much thought into it. All of these are equal intervals. Okay, and so there's my my new function. All right, so now it says that you're taking the absolute value of your x's. And so if I'm taking the absolute value of my x's, let's color show. So I'm taking the absolute value of my x values. So instead of negative 10, it's going to be positive 10. Instead of negative 7.5, it's going to be positive 7.5. Instead of, and that's what I'm taking the values of, okay? So absolute value, negative 10 is going to be a positive 10. Well, boop. And then I'm here, absolute value of, sorry, I had to take a potty break, restroom break because we're adults, my bad. Well, because I'm an adult, but I don't know what I was saying before I left. But here we go. So talking about what we have here. So you're taking the absolute value of negative 10, but that's just, it's still going to be at negative 10. It's saying if you take the absolute value of negative 10, you're going to be at 10. And what is the value at 10? 0. So negative 10 is 0. Okay. You're going to go here. If you take, you're still at negative 7.5, but if you take the value of negative 7.5, the absolute value of negative 7.5, that's going to be negative 8. So at negative 7.5, it's now negative 8. So you're going to come down here to negative 8. There. Okay. If I take the absolute value of negative 5, that's going to be at 5, and the value at 5 is 0. So it's going to be negative 5, 0. So I'm going to go to negative 5, stay at 0. Okay. I feel like that dot's tiny. I'm at negative 2.5. If I take the absolute value of negative 2.5, it's going to be positive 2.5, and the value at positive 2.5 is 8. So I'm going to go to negative 2.5, and I'm going to go up to 8. There. Okay. And then 0 is going to be 0. Now, you only have to worry about, you only have to worry about the negative x's because you don't need to take the absolute value of the positive x's. They're already positive. And so therefore, I'm just going to go ahead and put them where they are. So we're at negative 2.5, 8. We're at positive 2.5, 8. Positive 5, 0. Negative, positive 7.5. Negative 8. And we're at 10, 0. So now we look like this. Now pretend that I've gone through all the dots and that this is glorious because, you know, it is perfectly symmetrical. I don't know why it's so hard for me to draw. All right, a big mistake that you guys tend to do is that you assume that this number no longer exists. It's not that it no longer exists. It's just mirroring what its positive counterpart is. Okay, so negative 7.5 is still here, but its value equals its positive counterpart. Okay, so keep that in mind as you're doing it, and I'm going to leave you to do number 2 with absolute value of 2x minus 6. So remember, you're going to graph the linear equation. Remember slope and y-intercept. So you have your slope, you have your slope, and you have your y-intercept. So use that to create your graph. And then you're going to take the absolute value of f of x, absolute value of f of x, and then f absolute value of x, and create your graph from that. Okay? Okay, so example 3, well, not example, problem 3 on your review is a combination of transformations and absolute value, working with absolute values. And so if you look here, we're going to identify the transformation variables that we have. So the negative, that's going to be our a. This negative 1, notice how I said negative 1 because our x is a liar. This is going to be our c slash our h. And then this 4 here, that's our d slash our k. The reason why we say h and k is because in terms of a parabola and absolute value, usually you call these two your h and your k for your vertex. Okay, so let's think about our parent function table. So our parent function for a quadratic I'm only going to do 5. So I'm going to do -1, -2, -1, 0, 1, and 2. So our parent function is 4, 1, 0, 1, and 4. Now, because of what I have here, it tells me that a couple things are going to happen here. So for my new one, I have +1. So that tells me that to all of my x's, I'm actually going to subtract 1 because our x is a liar. And this +1 says that it's actually moving to the left. So if I need to shift this to the left, I'm going to have to subtract 1 from each one of my x's. So this is going to be x minus 1. So -2 minus 1 is -3. -1 minus 1 is going to be -2. 0 minus 1 is -1. 1 minus 1 is going to be 0. 2 minus 1 is going to be 1. So those are my new x's, okay? Now let's talk about what's happening to our y's. We have our a and our d, and our a and our d are affecting our y's. So the a tells us that we're going to multiply by -1 so that it can reflect. And then the d tells us that we're going to shift up 4 units, okay? So we're going to multiply by -1 and shift 4 units. So to each y value, we're multiplying by -1 and adding 4. So 4 times -1 is -4. -4 plus 4 is 0. 1 times -1 is -1. -1 plus 4 is 3. 0 times -1 is 0. 0 plus 4 is 4. And 1 times, well, it's going to repeat, so no point of saying it again. So we have 3 and 0. So these are the points that I'm graphing. So I have -3, 0. So I'm going to go to -3, 0. -2, +3. So I'm going to go to -2 and go to +3. We have -1, 4. So I'm going to go to -1, go to 4. We have 0, 3. And we have 1, 0. So as you can see, my quadratic, and pretend that this is like the best drawing you've ever seen. It's curvy and everything. My quadratic is negative. It was reflected over the x-axis. It was, compared to its parent function, it was shifted to the left and shifted upward. All right, so on here, it then says you're going to find the absolute value of f of x. So absolute value of f of x means that to all of my y variables, I'm going to take their absolute value. I'm not changing the x. So I have absolute value of the entire function, which would be my output, plus 4. Okay, and so this is my output. So all I'm doing is taking the absolute value of my y. Okay, well, for these, it's not going to have an impact, but it's going to have an impact on my values that follow. So as you can see right here, we don't have those values, but we can calculate those values and so that we can properly reflect them. So if we do that, that's totally doable, and we can go from there. Okay, so let's extend our original. So let's say we had included -3 and +3, right? Well, -3 and +3 is going to both be 9. After the transformation, my new x would be -3 minus 1, which gives me -4. And then we have 3 minus 1, which would be 2. My new y's would be, which is -y plus 4, would be -9 plus 4 is going to give me -5. And then same thing here, -5. So instead of being at -5, they're going to now be at +5. So when I graph my absolute value, these values aren't going to change because absolute value of 0 is 0, absolute value of 3 is 3, absolute value of 4 is 4, absolute value of 3, So these are still going to be where they are. So I'm going to plot those again. So I'm at -3, 0, still there. I'm at -2, 3, I'm at negative 1, 4, 0, 3, and 1, 0. Okay, so now though, if I look here at my my extended negative 3 and 3, there, when I take the absolute value here, it's going to be at positive 5. So positive 3, at negative 4, negative 5. So I'm going to go to negative 4, positive 5, and that's going to put me here. Oh, it's like something is off. I can't count, y'all. It is late, and y'all aren't here to correct me. Let's try that again. So negative 2, 3. 1, 2, 3. Negative 1, 4. There we go. Glad I hadn't connected them. So at negative 4, I'm at 5. At 2, I'm also at 5. So now what it's doing is it's going like this. Again, pretend that I'm curving. Oh, that's horrible. I can't even accept it, y'all. Try again. I don't know how people draw so well. I don't have steady hand. But now, instead of a upside down U, we now have a W. And again, that's because we're taking all that would be negative Y values and we're taking the absolute value of them, okay? Here, it's going to be a little different. So on this last piece, it's saying that you're taking F absolute value of X. So in terms of my equation, it's negative absolute value of X plus 1 squared plus 4. So that's what that would look like. Okay, so again, when you're taking the absolute value of the X and you're using the table, you are still at that value. So you're still going to be at our blue values as far as the X. You're just saying, what is its positive value equal to, okay? If you don't have the table, or if your graph isn't drawn pretty enough, or whatever it may be, you can just take the values and plug them in and see what happens from there. Okay, it's not going to hurt you to do it that way as well. So for example here, by taking the values, I'm saying that we can start at, where are we at on here? We could start at negative 4. So let's say I start at negative 4. I can plug negative 4 in here and evaluate. So I can find F absolute value of negative 4 and evaluate. So it's going to be negative absolute value of negative 4 plus 1 squared plus 4, right? So that's going to give me 4 plus 1 squared. 4 plus 1 is 5. 5 squared is 25. And plus 4, well, 25. And there's a negative, so it's negative 25 plus 4 is going to be negative 21. Well, I can't graph that, so that's too big for me to try to expand on. So it wouldn't be graphable. Okay, so sorry, I got a phone call or a message technically that I had to read. But so if I kept doing, this would end up being a lot to try to guess. But if we just remember that what's happening when we're taking the absolute value of our x's, that just means that our negative x's are just mimicking the positive x's behaviors. So for example, 0 is going to stay 0, so I'm going to still be at 0, 3, right? But what is happening at 1, so at negative 1, it's going to be doing the same thing that's at positive 1. So positive 1's at 0, so now negative 1 is going to be at 0. Does that make sense? So negative 1 is now at 0 because it's just mimicking the positive behavior, the correct behavior to follow. Okay, so again, when we have 2, we know that 2 is at negative 5. So positive 2 is at negative 5. So therefore, negative 2 also has to be at negative 5. There you go. and it'll just keep going down because it's mimicking each other's behavior. And what you create, it's going to be something very similar to, how can I say it? I guess if because it's not very curved, I don't feel. It's a tight curve. That's horrible, y'all. Me and this drawing. I feel like if you're going to be a mathematician, you also need to be a gifted artist. Okay. So it's like a very tight curve because it's still a parabola, but it has a little bit of the attributes of an absolute value in a sense. Okay. But the key thing here is that when you're taking the absolute value of the x, the negatives are just going to mimic the behavior of the positives, okay? Your negatives don't disappear. They're just going to do whatever the positives are doing. So if my positive is at 2, my negative is going to be at 2. If my positive is at negative, then my negative is going to be at negative, okay? You still have those values. Trying to create a table versus me plugging in numbers and figuring out where they're going to go, it would take longer to do that. But just to show you what I mean, so notice how we put -1 at 0. If I plug in -1 here, I'm going to get 1 plus 1, which is 2. 2 squared is 4. What is -4 plus 4? 0. I'm still going to get that. But if the numbers aren't as easy to plug in or you don't want to have to think like that, you can just use the fact that your negative numbers over here, I keep thinking, your negative numbers, so whatever's happening less than 0, they're going to mimic all of their positives. So they're just going to reflect, reflect, reflect. That's essentially what it's telling you to do. Okay? So, all right, that completes that. So we're on our last and final part, which was transformation. So we're going to talk about our transformation notation that we talked about in our notes. So we had f of x equals a f of b parentheses x minus c close parentheses double close parentheses plus d. Okay, so what this lets us know is that in function notation, your a and your d are affecting the output, which would be your y. Your b and your c are affecting your input, which would be your x. So let's look at this function. So we have y equals negative x minus 2 squared. So we're going to list out a equals, b equals, c equals, and d equals. A is what's affecting your output, what's on the outside of the function. And in this case, it would be this negative sign, which means that it's a -1. B, is there anything being multiplied to my x? And the answer is no, there is not. So we're going to keep it pushing. C, there is a number being added or subtracted to my x. Remember, our x is a liar, so it's not a negative because in the function notation, it's already negative. So that means that this is a +2. And D, there is nothing being added to the outside of my function. So looking at your chart in your notes, what is the A telling you here? Well, my A is telling me that since it's -1, that it's reflecting over the x-axis. Okay, what does my C tell me? Well, my C is telling me that it went 2 units to the right. Okay, and yeah, that's all you're doing. So you're identifying the variable, describing what it means, identifying, not the, well, the transformation variable, and saying what it means. Now we have an example of absolute value. So we have y equals the absolute value of 2 times the absolute value of x plus 1. So again, we're going to talk about a equals, b equals, c equals, and d equals. Okay? A, is there a number on the outside? Why, yes, there is. That is going to be a 2. B, there's nothing being multiplied to my x. C, yes, there's being something added or subtracted to it. And so therefore, if it's +1, it's going to be a -1. Okay, and D, there's nothing being added or subtracted on the outside. So now let's talk about what this means. My A equals 2, and this is greater than 1. So since my A is greater than 1, A is greater than 1, we call this a vertical stretch. by 2. My C is -1, so that means that it went 1 unit left. That left kind of looked like a, okay? And again, that's all you're doing. Do number 5 with you. We have y equals 1/3 x plus 2 squared plus 3. So I'm just going to identify what I have. I have an A, I have a B, I do not have a B, I have a C, and a D. Since my A is 1/3 and is less than 1, this is going to be a vertical compression. We have a vertical compression by 1/3. My C is +2, or it looks like +2, but it's actually negative. So therefore, we're going 2 units left. My D is 3, so that meant we went 3 units up. Okay, I'm going to leave you to do C6. On the next few slides, we are going to be doing the final part of transformations, part 2, I don't know what part 1, part 4, who knows. We're going to write the equation for the function y equals x squared with the following transformations, okay? For these, we're going to specifically be using the quadratic function y equals x squared, all right? So here it says I want to reflect across the x-axis, shift down 1. So reflecting across the x-axis means that I'm using a, and then my a has to be a -1. To shift down 1, that means that I'm using d. I'm going to have a d value, and my d equals -1. So again, we're using y equals x squared. A and d affect my output, so they're not going to have anything to do to the x. So my function is going to be y equals -x squared minus 1. That would be my function, okay? Let's do number 8 together. Stretch by a factor of 3, shift right 5, and up 1. If I'm stretching by a factor of 3, this is going, the fact that it's stretching by 3, that lets me know that this is a vertical stretch. So it's a vertical stretch by a factor of 3. So A equals 3. I'm going to shift right 5. So if I want to shift right 5, that means that my C equals 5, but it's going to look like a -5. Okay? And I want to go up 1. So D equals 1. And again, we're applying it to x squared. So we have y equals 3 parentheses x minus 5 squared plus 1. Okay? So here on 9, we have shift up 5. All I'm doing is shifting up. That means that's just D. Okay? So that leaves me with, I'm not doing anything to x. I'm just taking the whole function and shifting it up 5. So y equals x squared plus 5. I want to reflect across the x-axis and shift down 8. Okay? So again, this is A has to be negative. Shift down 8 means that D has to equal -8. So we have y equals -x squared minus 8. We're going to reflect across the x-axis and shrink by a factor of 0.5. So we're going to reflect across the x-axis and shrink by a factor of 0.5. The only transformation variable that can do this is A. So I know that my A, because it's reflecting, has to be negative. And then we're going to shrink by a factor of 0.5, so -1/2. So my function is y equals -1/2 x squared. Okay? It says stretch by a factor of 4, shift left 3, down 2. The stretching is my A, so A equals 4. The shift left 3, that's going to be my C, and it equals -3. But it's going to look like a +3. And I'm going to go down 2, which is going to be a -2. So that gives me y equals 4 parentheses x plus 3 squared minus 2. Okay. All right, lastly, let's look at it in terms of absolute value. And again, the rules don't change just because the function changes. So we have f of x equals the absolute value of x minus 2. And the transformation, all we have is our c. And c causes us to go left and right. Our x is a liar, so we actually went 2 units right. Okay, our x-intercept. So it's asking for our x-intercept. Well, if I was to graph this, where would my x-intercept be? Okay, x-intercept, solving it mathematically, we've talked about, that means you're taking this and you're setting it equal to 0, or in your case, you can graph it and see where it's at. But I'm going to show you algebraically. So if I take x minus 2 and set it equal to 0, where does it happen at? Where do I equal 0 at? Well, the only place that I'm going to equal 0 at is 2. So if x equals 2, right? 2 minus 2 is 0. So my x-intercept has to be at 2, 0. Okay? Your y-intercept is saying if you let x equal 0, so y-intercept is saying x equals 0, x-intercept is saying y equals 0, right? So if you let x equal 0, where does that put you? Well, 0 minus 2 puts me where? It puts me at positive 2. 0 minus 0. 0 minus 2 is negative 2, and the absolute value of negative 2 is 2. So my y-intercept is going to be at 0, 2. Okay, your vertex. And when we talked about vertex of absolute value, your vertex is your h and your k. In this case, for transformations, it's your c and your d. So my current h, c slash h is 2. And my d is 0. So my vertex is at my x-intercept of 2, 0. Okay? Is this going to be a max or a min? Well, my a is positive, and so since my a is positive, I have a happy v, which means that I'm going to have a minimum. Okay? Let's do this one. We have f of x equals the 2 absolute value of x plus 3. So I have a and I have c. Okay, A tells me that I have a vertical stretch by 2. 3 tells me it's going to shift 3 units left. Okay, my x-intercept. So if I wanted to find my x-intercept mathematically, I would have 2 absolute value of x plus 3 equals 0. Well, and up here, it's going to be the absolute value of x plus 3 equals 0. The reason being is to get it by itself, when I divide by 2, 0 divided by 2 is 0. So what would x have to be in order for this to be 0? Well, x would have to be negative 3. So my vertex is at, my x-intercept is at negative 3, 0. Okay? Again, y-intercept is saying that you're going to let x equal 0. So to find my y-intercept, it's too close, so I'm going to use a different color. So we have 2 absolute value of 0 plus 3. Well, 0 plus 3 is 3. Absolute value of 3 is 3. 3 times 2 is 6. So my y-intercept is going to be at 0, 6. Vertex. So your vertex, again, remember your vertex is based off of your h and your k. Well, here's our h. Our k is not there. It's 0, right? So we're at negative 3, 0. Okay? Our a is positive, so we have a happy v, which means that we still have a minimum. If our a was negative, then we'd have a sad v, but we don't. Okay, so that concludes our review. So along with this review and with your notes for the class and everything, you should be prepared. Hopefully you made your note card, and good luck.